Okay. All right, so we are doing test review for Unit 2B. All right, so let's just get through these as pain-free as we possibly can. So the first step for this one, your formula is, or your equation is that and this. So the first step is to, of course, factor the top and bottom, right? Stop me if I'm confusing you. Factor difference of perfect squares. I'm guessing this is going to be x plus 4 and x plus 3. Sure enough, it is. So these will cancel. So that means immediately we have an RC at x equals -4. Got it?
Wait, do you mean RD?
RD.
Sorry, I was like, wait a second.
I do mean RD. I don't know why I said RC. We have a removable discontinuity at x equals -4. And then when I plug that in there, f of -4, when I plug that in, I get -8 over -1, which is +8. So the whole is going to be at -4, +8. Got it? So there's our RD, -4, +8. Put that on a graph. Whoops. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8. There's my whole. Good. Then we can also see the vertical asymptote is going to be where the denominator equals 0, right? So the VASI is at x equals -3. So let's put that in there. Draw a vertical asymptote in blue. Got that? The X-Intercepts. We'll do this in red also. The X-intercept is going to be where the numerator equals 0. So look at what's left in my numerator. So x equals 4. So 4, 0 is my X-intercept. Got it? So there's my X-intercept over here. My horizontal asymptote, we'll do this one in green. The horizontal asymptote, I find that by looking at the degrees of the numerator and the denominator there. I can see that they're the same. So the horizontal asymptote is just the ratio of leading coefficients, which is 1/1. So y equals 1. Can't see that very good. I'll do that in yellow. So there's my vertical or horizontal asymptote. There's my vertical asymptote. And that's really all I need to know. Now I can see exactly what's going to happen. So I can confidently know that my graph's going to look like, oh, I do need the y-intercept though. Let's find the y-intercept first, because it's always good to have that on the, they want us to answer it. So plug in 0 for x and I get -4/3. So that's -1 1/3. So it's like right there, which checks out, right? Because
Yeah.
my graph, I knew it was going to do that. And of course, that means the graph up here does this. Okay, so filling in the rest of this, we can see the domain is everything but where the denominator equals 0. So it's from -infinity to negative, where's the whole RD? -4. Then from -4 to -3. Then from -3 to infinity. You understand that? Because as I'm scanning, I think where am I not going to touch it? Right there at the hole and right there at the RD, which both have to do with the original, the original equation. What you're not allowed to plug in basically for that. Gotcha. Right? Let's see. There's no SLASI. I already did the x and y intercepts. For this right here, that has to do with, of course, the horizontal asymptote. So that's just 1 for both of them, right? And the range, I scan it from bottom to top, and I ask, when am I not going to touch the graph? 2 places. One is here at the horizontal asymptote.
Yeah.
So that's at 1. So it's from -infinity to 1, and then from 1 to, notice that the whole also, which is at 8.
Wait, oh, up. Okay.
It's at 8, right?
Yeah. Yeah.
at 8, and
One.
then from 8 to infinity.
Okay.
Okay, makes sense how we did that?
Yeah.
All right, so it's next one. So again, we're going to deal with, now right away I can see that I'm not going to have any holes. You know how I can tell that?
Because the it's squared on top and on bottom.
That's not why we won't have any RDs or holes. The reason is because there's no, I can tell right away that there's going to be no factors that they have in common.
Oh, okay.
So it's always good to it's always good to factor it anyway, even though nothing's going to cancel out, because that helps us see things better. Okay.
Yeah.
So the domain, well, sorry, let me just do it in the order, and then I'll fill in your sheet. This is the order I like to do it in. I like to look for holes first, and I see that there are none because nothing cancels. Then I like to find the vertical asymptotes next, because that's where the denominators equal 0. So at x equals -2 and at x equals +2. So those are my asymptotes. So I'll do those in yellow. Those are my vertical asymptotes. I've got 2 of them. Then the next thing I like to do is to find the X-intercepts. And that's because that has to do with where the numerators equal 0. You understand my thought process here? So the
Yeah.
X-intercept is at 0, 0. Because when I set the numerator equal to 0, I just get 0. You understand that? Also,
Yes.
I'm gonna add a little thing. I'm gonna put M2 next to that with the circle. And I'm gonna put M1 next to each of the VASIs. And here's the reason why. Let's go back to the last one. Whenever you have an X-intercept, like I have right there, the multiplicity of that, and that means, look at the factor that came from. Look over here, x minus 4, that was my factor. The multiplicity is the number of the exponent on that factor, basically. If the exponent is 1, that's got multiplicity 1. If the exponent was 2, which it's not, it'd have x multiplicity 2. If it was 3, it'd have multiplicity 3, etc. The reason this is so nice to know is because with X-intercepts, the multiplicity tells you whether the graph goes through that point or bounces off that point. And when it's an odd multiplicity, it goes through that point. Remember we talked about this before?
Yes.
And then for vertical asymptotes, the multiplicity also helps you. See this one? That also has a multiplicity 1, which is odd. And for vertical asymptotes, that's helpful because it tells you about the direction that it's going to be approached from both sides. If it's an odd multiplicity like this one is, -3, then it's going to approach it from opposite directions. It's approaching the asymptote from opposite directions coming from each side. Okay, why is that so important? Well, right now I can see that I have a multiplicity. I have an even multiplicity for my 0, which means I'm going to bounce. When I put this on the graph, I know it's going to bounce. It's either going to bounce
up,
both going, it's either going to be going like this or like this.
Yeah.
It's not going to go through. Okay.
Yeah.
So that's an important thing to note. In fact, you might as well just check it right away if you want to. And we're going to have to probably do this anyway. If I plug in 1 here, I'm going to get a negative on the bottom. So it's 3 times -1, which is -3, and I'm going to get a negative on the top. So it's a negative over a negative, which is a positive. So when I plug in 1, I have a positive, which means it's going up like this. In fact, it's got to go up on the other side too because it bounces.
Yep.
That makes sense?
Yeah.
And you'll see why that's really nice to know when we get to this next part. So now let's find our horizontal asymptotes. And you'll see that the degrees are the same on the top and bottom, right?
Yeah.
So what is my Hasse?
0.
Note when they're the same.
1.
Nope. It's
No,
the
wait.
ratio of leading coefficients. What's the coefficient of the top?
The 2.
-2. And on the bottom, what's the leading coefficient?
2.
Nope, it's
Or
1.
1. Oh, wait.
Yeah, leading
Why
coefficients.
did I
Here's your
totally
leading
forget to do
coefficient.
that?
You understand that?
Yeah, sorry. I just totally forgot that. I didn't do it in a while.
Yeah, you definitely have to remember that. That's important.
Yeah,
So
I knew that and I forgot it because
yeah,
I
I
was
know,
out for like.
I know you've done it before. Just don't ever
Yeah.
let it happen again.
Yeah.
Better to
I
make the
won't.
mistakes here than on the test tomorrow.
Yeah.
So there's that, and then I don't have any y, or the y-intercept is the same thing as the x-intercept, right? Because I already have it. I can't have 2 y-intercepts, right? So since I already have
Yes.
one of them, that's it. Got it?
Yeah.
And then, all right. So tell me what I know has to happen over here. Is it going to be going like this, or it's going to be going like this?
The first or the other way, the second way you did it.
Yeah.
Yeah.
Why do you know it has to go? There's 2 reasons actually. Why do you know it has to go like this?
Because it's negative, not positive.
That's not why.
I don't know. I just I totally guess.
Well, there's a couple reasons. Number one, if it was up here, what else would I have? What would I have another of? What would I have? What would have to happen right there? Do you see how I'd have to have another x-intercept?
Oh yeah.
And I don't have
Yeah.
another x-intercept.
Okay.
But there's another reason. Remember I talked about the multiplicity of the Vacies?
Yeah.
See, all of
If
these
it's
things
an
help
odd
you
degree in
check
the
your work.
denominator,
Yeah,
then it
since
can-
it's odd, since we knew this went up, we know this has to go down.
Yeah. Okay. That makes sense.
That makes sense? How about
Yeah.
this over here?
That one has to go down too.
That's right. For the same reasons, right?
Yeah.
Now, your teacher doesn't care about you drawing it perfectly accurate. So you can just kind of roughly estimate it there. And then, of course, this is -2 and -2, and the rest of them we filled in. Make sense how we did that?
Yeah, it does.
All right. Now, what do I know about this one? What's this going to have?
This one. Wait 1 second. Sorry. I was writing down those notes real quick.
Yeah, no problem.
This one's gonna have an RD.
It might. Let's find out.
No.
Let's find out. If it has an RD, what's the top have to factor into?
It has to factor in x -1.
It has to have an x -1, which means the other one would have to be 2x
Yeah.
plus 2,
Yeah.
which doesn't make sense. That can't be true.
Yeah. Never
So
mind.
actually, no, that
Doesn't
didn't
have
happen.
RD.
So it doesn't have an RD. That's not how it factors, but it's good to check that. Let's see if it factors into -2 here. Oh, yep, here we go. -2 and +1. Does that work? Because then I get -4x and +2x, which is -3x. So yeah, that worked.
Yeah, it does. Yeah.
So no RDs, right? So let's go
Yep.
through the checklist. No RDs because no factors canceled. The VASI is going to be x = 1, right? Bottom, the denominator.
That equals 0.
Good. What's the x-intercepts going to be?
You set the numerator equal to 0, so it would be
So what am I x-intercepts?
2 and 2, 0, and 1. Or
-1.
wouldn't you plug in -1, -1/2?
Yeah, remember
yeah.
you're setting each of those equal to 0. 2x plus 1 = 0, which means 2x = -1, which means x = -1/2.
Over 2. Yeah.
That's how you're
plugging
doing
in.
that.
Yeah.
Remember?
Yep. I accidentally
Okay, now
plugged 0 in.
this is what I was saying earlier. What is this going to have? I wasn't thinking RD. I was thinking because the numerator has the degree 2 and the denominator has degree 1. I was thinking, oh, we probably have a SLASI here.
Oh, I hate SLASIs.
SLASI. So no HASI. So I can write none for that. So the SLASI, I'm going to find that by doing a little bit of long division here. So here we go, 2x squared minus 3x minus 2. That goes on the inside. X minus 1 goes on the outside. I say this divided by this is what? And I put it up on the top. That is 2x, right?
Yeah.
And then I multiply that back down. I get 2x squared minus 2x. And I distribute the negative in here. So that becomes a negative and a positive. So this becomes negative x minus 2. And I divide this by this. And what do I get?
A negative or negative x, yeah. A negative 1 x.
Yep, I get negative 1. Not negative 1x, just negative 1.
Negative 1.
Oops, let me change the color to green. Negative 1. Multiply that over and drop it down here. I get negative x plus 1, right?
Yeah.
And distribute it. Not that it really matters. It doesn't really matter, but I have negative 3 left over here. That doesn't even matter, the remainder. All that matters is that
2x minus 1.
Sorry, I lost it. All that matters is that I now have my SLASI. So my SLASI, slant asymptote, is y equals 2x minus 1. So let's draw those in here. 2x minus 1, so it's going to start at negative 1, and it's going to have a slope of 2, so up 2 over 1. So there's my line like that. Remember how to graph lines?
Yeah.
Good. Just checking. And then my VASI is 1, so it's this right here. Okay, my X-intercepts, I have 2 of them, which is nice because that's going to probably give me everything I need to know. There's one of them, and the other one's at negative 1/2, which is right here. Yep, that gives me everything I need to know. Well, I could find my y-intercept as well. That never hurts. So the y-intercept, when I plug in 0, I get negative 2 times 1 all over negative 1, which is what?
Negative 2 or negative 2.
Positive 2.
Wait,
Negative
2.
negative 2 over negative 1.
Oh, 2.
Which is good because it better go up, right? Because it's not going to go down here. I know it's going to go, I know this has to go up like this. If I have this point right here, I know that my shape has to do something like that. And this shape is going to do something like that.
Gotcha. Okay.
Now, if you make one mistake, any one of those things, you make a mistake, then your graph's something's going to be messed up on your graph. You're going to be like, what'd I do wrong? What'd I do wrong? And that's the key with these problems is all of the things that you're doing, including that multiplicity thing I was just teaching you. All of those things have work together to make you know you're doing it right. But if you do one of them wrong, then you get it gets confusing and you get lost and you're like, what I do wrong? And you're trying to figure it out again, and it's not easy to find. Okay.
Okay.
All right. Let's do another one. Oh, what do they want us to do here?
They want us to answer everything according to the graph.
Right. So watch how easy this can be with the just tricks I just taught you. I can see that my VASI is at x equals negative 3, which means x plus 3 equals 0 is a factor, right?
Yeah.
And I can see it has to have multiplicity 2 or 4. Why? Because they're both going up.
Yeah.
So I know that that's in my denominator. So here's my function. I know my denominator has to have x plus 3 squared probably in the bottom. And then I don't have any X-intercepts. So that's nice. I don't have to worry about factors in the top. Got it?
Yep.
I see no holes. And that's nice because I don't have to put an extra factor in the top and the bottom. I'll just put yay here. And I guess the only other thing I have to do is check the y-intercept. What's my y-intercept? Now let's say I just put a 1 up here. What would my y-intercept be if I just put a 1 up there?
Wouldn't it be 0? Wouldn't it just be 0?
No, it's not going to be 0. Y-intercept, I plug 0 in for x, and then I simplify this. What's 0 plus 3?
Oh, 3. It would
3
be
squared?
6.
No, what's
Oh,
3
9,
squared?
9, 9, 9.
Yep, and what's 1 over 9? Your y-intercept. Hey, does this look like it's about 1 over 9 down here?
No.
Look at it.
Well, yeah, it does kind of.
Yeah, it's close
It's
to 0.
weird though.
But you understand what I'm saying?
Yeah, I do.
Now, what if the point was up here somewhere? What if the graph looked just like this, but the point came here? You know, all you would do is fudge this data, and you would make this, instead of making this a 1, you would make it a 9. Because making this a 9 would give you 9 over 9, which equals 1.
Mm-mm.
You understand what I'm saying?
Yeah, I do.
But it's not. So just leave it like that. But that's the trick. That's the way that you do that. So let's do this one. Ready? This is fun. Here we go. I see a hole, an RD. The RD is at 2, which means I'm gonna start building my formula down, or my equation down here on the bottom. F of x equals, so I know that x minus 2 has to be in the numerator and the denominator. Got it?
Yeah.
So I'm gonna write x minus 2 in the top and bottom. Now let's find the vertical asymptote. I have a vertical asymptote at -4, which means x plus 4 has to be in the denominator. See, I'm just building it.
Yeah. Yeah.
Now my x-intercept, you remember I was talking about why I do these in the beginning? This is the reason I do all 3 of these together, because it helps you when you're going backward. The x-intercept I see is at -1, which means what?
X-intercept is you're setting the numerator equal to 0.
So x plus 1 is in my numerator. Oh, this is awesome. So the only other thing I need is the horizontal asymptote and the y-intercept. The Hasse, and usually they work these out nicely, and also the RD, making sure that the y coordinate is correct. What should the Hasse be? What is the Hasse?
Y equals 2.
And if y equals 2 and the degrees are the same, what do I have to put in the top here? What do I have to put up here? How do I find the Hasse?
For the Hasse, don't you wait, don't you look at the degrees on top and bottom?
Yep, but if the degrees would have to be the same, which they are, right?
Yeah.
They're both degree 2, but then you take the leading coefficients, right? The ratio of leading coefficients.
Oh, it would have to be 1.
It has to be 2. So I need to put a 2 up here.
Oh, okay. Yeah, you're right.
Got it. Now let's just check if everything else works out the right way. What should the y-intercept be?
The y-intercept, isn't it 0, 1/2?
It looks like about 1/2. And let's test it. Let's see if that would have worked. If we plug in 0 for all these x's, let's just see if it works. We're going to have a -2 times a +2 times a +1. So that's -4 all over -2 times a +4, which is -8. What's -4 over -8?
1/2.
+1/2. Hey, that worked out. And how about if I plug in 2 for my RD? I'm just checking. If I plug 2 in here, remember these are canceled.
Yeah.
If I plug 2 in here and here, I get 3 over 6 times 2. 3 times 2
6
over 6, which is 6 over 6, which is
1.
So it actually worked out. See how that works?
Yeah.
But the key here was we find these things first. Those are the three things that you look for because those tell you the factors that you have in your function. The RD tells you the factors from the top and the bottom, the numerator and denominator. The VASI tells you the functions you have or factors you have in the denominator. The X-Intercepts tell you the factors you have in just the numerator. And then the HASI, you have to kind of do a little bit of thinking with that. And then the leading coefficient that you're going to put out here has to do with the HASI, or it might have to do with the Y-intercept, or it might even have to do with the intercept of the removable discontinuity.
Okay.
Or the intercept. Was that it?
Yeah, that's it.
That's perfect.
Perfect.
All right, you feeling good about this?
I am. And I also, okay, so for tutoring, instead of on Tuesdays, me and Micah and Izzy talked and we all start work. So we were wondering if we could switch it to Thursdays, 3:30 to or 3:30 to 5, whenever time we did it
Um,
for in person instead.
let's see. Hold on one second.